Hello, we're going to look at direct proportionality today, quick crash course. So this refers to if two quantities, if they're directly proportional, as one quantity increases, so does the other. It also holds the other way as well. As one decreases, the other also decreases. So the key thing to know, first of all, is that if two things are proportional to, these are the two words you're looking out for. The special symbol that you will write down immediately is this one. So if A is proportional to B, for instance, you'll say that. In fact, you don't need those lines underneath, just emphasizing. Okay, so there we go, it's the proportionality sign. So let's look at an example. The more fuel that Freya buys for her car, the more discount that she receives. Okay, write an equation that links the volume of fuel to the discount. So they are proportional to each other. As one increases, the other one increases as well in the same ratio. So volume is proportional to discount, let's say. Okay. Now, what we can actually do is we can, at this point, also know that this proportionality sign can be replaced by E equals K. All right. So what that does is we actually now write down V equals KD. All right. Now, the K doesn't mean anything at the moment, but if we start to look for the common ratio between these sets of values, we'll be able to work out K and work out any volume given the discount or any discount given the volume. So let's take the first column here. Okay, let's put these values in. Volume is 5 equals K times 0.25. Okay, so therefore K is equal to 5 divided by 0.25, which equals 20. Okay, let's try it with some other ones and make sure it works. So the volume is 20 multiplied by 0.6. That's right as well. 18 is 20 times 0.9. Obviously, that's nice and easy to see. 2 times 20. And 2.25 times 20 is 45. So now that we've found out what K is, now we can rewrite this as V equals 20D. Okay, all right. So that's what they asked us to do in the question. Write an equation that links the volume of fuel to the discount. Basically, the volume is 20 times bigger than the discount. All right, we did it through that method. Now let's look at a bit more of an involved example. Example 2. The flow rate of a square pipe is proportional to, okay, there's those words, and there's the proportionality sign, to the square of its width. We say that R is proportional to the width squared. This means the larger the hole in the pipe, the greater the volume that flows through it. Well, that would be logical. The flow rates for different widths of pipe are given in the table below. Can you spot a formula? So we're going to do that same idea, and we're going to now take this, and we're going to replace, as I said before, a proportionality sign with equals K. All right, so what we can say is that we take this, let's do it in full, R equals K W squared. All right, now it's just a case of now investigating what K is by substituting in a pair of values for the width and the flow rates. Okay, so here R is 125, let's get them in the right order. 125 is equal to K times by 5 squared. Okay, 125 is 25K, therefore K is equal to 5. And so the formula, let's put it back in now. If we put the K is 5 back into this, we've got a formula that links R and the W, which is R equals 5W squared. Okay. Obviously, you can put these values back in. Okay, so you could try 15 squared, which is 225 times by 5. Yes, that's 1,125, for instance. You can go double check and make sure that that's correct. It is. Okay, so then we've got this one. If the width of a pipe is 30 centimeters, so they're giving us W. W is 30. What is the flow rate? All we have to do is substitute W equals 30 into here. Okay, and so R, what's the flow rate? R would be 5 times 30 squared, which is equal to 4,500, I think. My calculator right now. But I think, yeah, 900 times 5, 4,500. Okay, what width of pipe will give a flow rate of 5,000 gallons per minute? Okay, so now it's wanting us to find W given the R. So we're going to set R equal to 5,000. We can say that 5,000 is equal to 5W squared. Well, let's just rearrange this and find what W is. Divide by 5, that's 1,000, equals W squared. So that means that W is the square root of 1,000. Okay, and we can work that out. Which equals. So I've got all my equipment with me. We've got square root of 1,000, which equals 31.6. We could just check. We could actually just leave it as square root of 1,000 to W equals sorry about that, 31.6. And what are we? Okay. Yeah, gallons, isn't it? Is it? Oh no, centimeters. Centimeters. It will be. It's the width, isn't it? 31.6 to 3 significant figures. Okay. All right. Let's go on the next one. Example 3: proportional to the square root. So now it's a lot less information if you compare the size of that question to the last one. But it's all we need. Okay, so y is proportional to square root of x. Oops, let's make that a bit more. Apologies. Let's do this again. Square root of x. Okay, so we just immediately change that into y equals k. Square root of x. We change that into equals k. All right, then we just go and put in a pair of values. And there's only one pair of values that's given to us in this question. That's all we need. Okay, so when y is 3, when x is 36. Okay, so 3 is equal to k times 6. 3 equals to 6k. K is equal to 3 over 6, or 1/2. Okay, so if we now go and improve on that formula there, now we've found what k is, it's 1/2 of root x. Now, what is y when x is 64? Y is half times the square root of 64. We know that the square root of 64 is 8, so it's half of 8, which is, of course, 4. Okay, so it's actually, on the face of it, it looks like a difficult topic, but hopefully that's not looking too bad at this stage. Let me know any questions. Okay, so the key things here, proportionality sign is equals k, and you're pretty much laughing once you get that. Okay, good luck.